All right. Compound interest or compounded interest, and here we're going to look at how to find the time. And common questions for this would be when we're asked to find the time is, how long does it take for my investment to double or triple, or you know, how long does it take so that I have 3 grand? How long does it take until I have 5 grand? Something like that. They're all going to work out real similarly. Um, And so what we're going to do is we're going to isolate the exponential part. That's the parentheses 1 plus r over n to the nt. So to do that, we're going to divide by p. Okay, so we'll have a over p, and that's going to be equal to 1 plus r over n to the nt. Okay, and we're solving for the time. The time is an exponent. So to do an exponent, we need to use a logarithm. And we've been using the ln most of the time. You can use the regular log. You can also rewrite it as a log and then use the change of base. There's a bunch of different ways of doing this, but ln is less writing, so we're going to ln both sides. It's a nice function. Um, so we're going to ln both sides. So we're going to have the ln of a over p, and that's going to equal all the other junk on the other side of the equation. Okay. And then we're going to use the power rule to bring down that nt. I'll bring that nt down. Okay, so we'll have ln of a over p is equal to nt times ln of 1 plus r over n. And all right, so attached to the t is the n, and then the ln of 1 plus r over n. And that's all attached by multiplication, so we're going to divide by all that junk. So n ln 1 plus r over n. I'm going to divide both sides by that. And then I'll write it how we would put it in our calculator. So it'll be t is equal to ln parentheses a over p, close parentheses, divided by parentheses. And this parentheses is very important. Anything in the denominator needs to have parentheses around the whole thing. That calculator is not as smart as you, so you need to help it out. Okay, so the n ln parentheses 1 plus r divided by n, close parentheses for the ln, close the parentheses for the denominator. And that's how we'll solve for the time with these things. When we start getting into continuously compounded interest and exponential growth and decay, those are going to be a little bit easier because they are base e and the natural log, and e are inverses, so it's just a little bit cleaner. Okay, all right, so let's do an example, and we'll speed it up. Okay, so here's a common question. How long would it take an investment to double in an account which earns 4% interest compounded annually? And they don't even tell us what we're initially depositing, and then in fact it doesn't matter. It doesn't matter what it is. Okay, so I'm going to write down the A, the P, the R, the N, and the T. And if you want to pause the video for a moment to try to plug in everything that you know, go ahead and try that. I'll give you a hint. You can just let the P equal P and think about what the amount would be. Okay, so you gave yourself a little bit of time to try that out. Let's see which we get. So the time is what we're trying to find. Annually means once a year, so the N is 1. The R is 0.04. The principal we said we call P, so double that would be 2P. Now, let's say I ask you to triple it, then it would be 3P, quadruple it, 4P. You get the idea. So the amount is 2P, and that's equal to P plus 1 plus R over N to the NT. But we'll plug in the stuff that we know. We know that the interest rate is 0.04, N is 1. So plug that in. So like before, we'll divide by the principal. So we get 2 is equal to, and this time this is pretty easy for me to figure out. I can't always figure out what this is sometimes. I don't really want to divide it out because then I'm going to introduce some rounding error, but that's really nice. 0.04 divided by 1 is 0.04. So it's like 4 cents. 4 cents plus a dollar is $1.04, which is what we got there. So that kind of works out nicely for us. Okay, t times 1 is t, so that's our exponent there. All right, exponential is isolated. We're going to go ahead and ln both sides. Again, you don't have to ln. There's other options, but this is probably the less writing option. And use that power rule to bring down that t. So we got ln of 2 equals t times ln of 1.04. And that ln of 1.04, it's just a number. I don't know what it is without my calculator, but I can divide both sides by it. And so it's important when I do this in my calculator, ln2, to close that parentheses. See those parentheses there? It's really important to have those closed. And then divided by the ln of 1.04. Okay, and punch that into your calculator. Don't punch it too hard, but we get 17.7 years. And that is how long it's going to take with this particular interest rate compounded annually for it to double the money. Doesn't matter how much money we put in. That's how long it's going to take to double it.